Hello, I'm Mike Eisensee. I'm the administrator of the Middle St. Croix Watershed Management Organization, and I'm going to be doing a quick overview of the Minimal Impact Design Standards Calculator for you today. Now we're going to walk through the Minimal Impact Design Standards Calculator. When you click on the icon, you're going to see this title page pull up. In order to start using the MIDS calculator, the first thing you'll need to do is create a new file by going File and New. And today we'll label that file Example. Once you create a new file, it's going to take you into the MIDS calculator, and you're going to see the site information page pop up as soon as you get on. The first thing you're going to notice is on the left-hand side, there's summary information. As you start inputting information into the white boxes, you'll see that this progress tracker, essentially, or the summary, will start updating. So the first page that we're on is site information, so we need to enter in a project name and username and a date. Today what we're going to do is we're going to create a scenario for a 3-acre parcel that has 1 acre of impervious surface, such as rooftops, driveways, or streets. And we're going to put the zip code in for the site. We'll set that in Minneapolis. Okay, and then down below you'll see that there's an opportunity to input a summary of your land cover. So what we're going to say for this site is that the site has 1 acre of kind of forest open space. This could be woods, etc. It has 1 acre of managed turf. So this is definitely not a typical small suburban lot, but probably a large suburban lot. And then we'll say that we have a combination of 1 acre of new impervious surface. Once this information is inputted, then we'll go up to the top and we'll click on the schematic tab. And you'll notice that once we moved over to the schematic tab, our information that we inputted has updated on the left-hand side. So you can see that per MIDS, the Minimal Impact Design Standards Performance Standard is to try to capture 1.1 inches off of all impervious surfaces. So it's going to set a MIDS performance goal of 3,993 cubic feet. So now what we're going to do is we're going to look along the left-hand column of our schematic, and we have a number of best management practices available to us that we can use to capture, infiltrate, or filtrate this water. And what we're going to look at today is a bioretention basin without an underdrain. So we're going to click on that bioretention basin and move that over. So this would be fairly typical for an area of sandy soils. And so then in order to input information into that bioretention basin, we can double click on it like this, or we can right click and edit the BMP properties. Now what we'll do is on our schematic page, we had a 3-acre total site, and we're going to make the entire site drain to our bioretention cell, which is the engineering term for a rain garden. And so we're going to put that information in here. And so this is the water that's now being routed into our rain garden in the watershed tab. And next what we'll do is we'll click on the Bmp Parameters tab, and we'll tell the calculator a little bit about our rain garden. So we're going to actually do a really large rain garden in this one. Basically what the calculator is going to be looking for, this is the equation that it's running, and it's going to need the overflow of the surface area, the total depth of the rain garden, and then the overflow or the surface area at the bottom. So just to keep things simple, we're going to say we've got 2,000 square feet at the top and 1,700 square feet for the bottom surface area, and we'll make the rain garden 1 foot deep. And at this point then it's going to ask you to input the hydrologic soil group for the rain garden. There's a number of different hydrologic soil groups. Where these actually come from is from the Minnesota Stormwater Manual, and each soil group has a slightly different infiltration rate, which will determine how well your rain garden will perform when calculating the pollutant load reduction. So where you can find that, I'm going to switch over to my Minnesota Stormwater Manual page here. And where I'm at in the Minnesota Stormwater Manual is I'm in the bioretention section under Design Criteria for Bioretention, and you can see that I'm about 3/4 of the way down the page. What this is this is the design infiltration rates for A, B, and C soils. So you can see that when we're looking at soil types, hydrologic soil groups basically tell us how quickly the soils drain based on their characteristics. And so we have our hydrologic soil group A, B, C, and D. D soils are very poorly drained, typically do not do well infiltrating water. C soils are generally your clays and silts. B's are silts to sandy silts, and A soils are sands. So for our project, what we're going to assume is we're going to assume we have a loamy sand soil, which is fairly typical for some of the outwash areas of Minneapolis. And the description for that in the Unified Soil Classification is a gap-graded or uniform sands, generally sandy soil. So going back to our calculator then, we will select that SP soil. And that credit for that infiltration rate, or a design infiltration rate, is then 0.8 inches per hour. And the Minnesota Stormwater Manual and the state permit requires that our infiltration practices be drawn down within 48 hours, and that's to prevent mosquitoes from propagating, as well as making sure that our basins are ready for the next storm event. And it's also beneficial to have our basins draw down within 24 to 48 hours to ensure better plant health, that we're keeping our upland plants alive and vibrant, and not transitioning to wetland plants. So once we input that information, we can take a look at how our rain garden is doing by clicking on the BMP Summary tab. On the Summary tab, you're going to see our performance goal summary. So I said that our MIDS goal was to capture and infiltrate 1.1 inches off of all impervious surfaces, and it looks like our rain garden is currently achieving 46% of that goal. And then it also gives us what our annual reductions are for loads. So we're going to be basically capturing and infiltrating about 1.9 acre feet of water on our average rain year, and reducing particulate phosphorus by 0.9 of a pound, and capturing dissolved phosphorus as well, and infiltrating that dissolved phosphorus, 0.73 pounds per year. And then it looks like we'll be also capturing, we're estimating that we're going to be capturing about 295 pounds of TSS. So now you can see that information is also reflected in our summary information on the left-hand side. And that's just a quick overview. There's more information available in the Minnesota Stormwater Manual, and example exercises that you can go through modeling a number, or calculating a number of different best management practices to reduce stormwater runoff and their associated pollutants.